And second, I'm going to share. Let's see, here. Well, to share my desktop. So, well, as I was saying before, I'm going to continue with Geoda. So, if you remember, the last day we could see how to, for instance, how to build a map from the X and Y longitude or latitude coordinates very easily and quickly in Geoda. So, Geoda is a software. Oh, let's see. I'm going to close. It is quite easy to use. Oh, sorry. I'm going to put, you remember the sheet in blank because if not, Yoda is messy in the sense that it has only this only menu here that is mobile, and everything is going to be floating. So, but well, if you forget about this issue, Yoda is quite easy to use. At least it is, you can use it very quickly for exploratory analysis. This is why I wanted to use it, but I was surprised because when reading your feedback, so I appreciate a lot, and even I put a score to your feedbacks because I consider them very important. So for instance, I thought that most of you were going to know Yoda, since it is quite easy and I think that well known. But I've seen that not. I was wrong. So the majority of the DASEE students, I think, you don't know how to use Yoda. So for me, it's interesting to dedicate a little bit more time to this software, since it is, as I say, very easy, very quickly to explore data. So as I told you the other days, exploratory analysis, spatial analysis, spatiotemporal, whatever analysis, exploratory analysis is crucial before modeling, before saying anything about data. If you don't know data, you can say very stupid things in the end with your models. So don't forget, if you have data, unless you know it very well in advance, please explore it. And Geoda, it's a very good tool to do that very, very quickly and, in a very easy way. So it's a point and click software. So going to the other class, yes, another point. So if I dedicate more time to Geoda, and to deal with the database. So I don't know if you have realized that for me, it is very important, not only theoretical issues, but practical ones. If you don't know how to use the software, how to apply the theory, it's more or less as if you don't know anything. You cannot do anything. So for me, it's important to dedicate more time, if necessary, to software issues in order to allow you to make computations and to extract outcomes from data. But if I dedicate more time than expected to Geoda, R, or whatever software, perhaps or almost for sure, we are not going to have enough time for the last day for the presentations. So if you remember, I wanted you to present your databases and your outcomes, applying the software the last day. And maybe we are not going to have time. So let me think about that. Perhaps, I prefer, of course, to dedicate the last day just to finish with these methodological steps that I proposed you last day. And if we don't have time for the presentations, maybe I will ask you to record yourselves and to upload your own presentations to Moodle, so I can correct them. So it's one chance for evaluating this part of the topic or the topic, this topic in these sessions I'm going to give you that are part of a whole course. So let me see, but perhaps this is going to be the last, or the definite option. You are not going to present your papers the last day, but you will have to be preparing this presentation because you will do by yourselves in your own homes, and you will be must in like 2 or 3 days after, you will have to upload them to Moodle. Okay, this is perhaps what I'm going to ask you. I will tell you for sure next week. Don't worry. You will know that in advance. So as I said, I preferred to stop a little bit, or to to dedicate more time to these issues regarding maps. For instance, if you remember, we were like here. This is my hard disk, and we were working with this Chile map shapefile. So this Chile map was, the representation, because it is the representation from the Earth coordinates from, well, first, this was this initial panel that it is a pool. So I asked you, please, to use something like pivot tables in order to present all the variables. So in rows, the spatial units, and in columns, if you remember, the time periods, okay? And we extracted, if you remember, we extracted part of the map selecting using this menu. But first, we had to look for this city base. In this city base that must be stored in the previous XLS format for Excel. If you remember, what we had here were the coordinates. The coordinates are the first step, as I was saying before. So it is completely necessary to have the coordinates. So here I have the coordinates for the Chilean cities, main cities, and this was what I was going to depict on a map. This was the first step. So as I showed you, Geoda allows you to import. So, oh, excuse me, to import here in this folder, open. It allows you to read DBase databases or Excel files, but this format, the old one. So we imported this previous Excel file, and from the previous Excel file we build, with the X and Y coordinates, we build the map. So, and we could see the map. So apparently this map is correctly depicted. Why? Because though it is unprojected, as we could see the other day, but it has the coordinates, so it is possible, even to have the base map here be behind. So if I select like this cartolite, I see, the municipalities or the towns in their correct place in Chile. So it is not in Africa or in Europe, it is in Chile. So they seem as if they were correct. But when I tried to superpose, or, to put on this layer, a new layer with a map that has its correct projections. So for instance, I superpose these FLMAs. So they are the functional labor market areas in Chile. And they had the projection. How do I know? Because this map, besides the 3 necessary files, the DBF with the database, the shape, SHP, with the coordinates, and the SHX that connects the coordinates with the database, I have the PRJ. The PRJ is for the projection. If I open with a notepad or whatever other text, basic text, or even Word software, I can see that it is projected. it has one of the main, mostly used projections, 1984, UTM, etc., WGS. Well, Anselen explains very, very well, to my opinion, but it is not easy to explain all these geodetic issues, at least for the ones that are not geographers from our origins, you know. We like geography, but particularly me, I'm not a geographer. So it is a little bit messy. In fact, he also says so. If you look at here in Geoda workbook, I recommended you to go to this spatial wrangling to GIS operations. I think that they are here because, well, Luke tries, you know, to transmit us all these issues about projections. So projection is basically that you have, you know, a spherical, a 3D object that is the Earth. No, it is like well, it is a near spherical, as he says here. It is a near spherical Earth, but you must project these points that are in a globe to, you know, a 2D plane surface. And this is the problem, that there are many ways to do that and to conceive the Earth. And this is the messy thing. These, you know, different ways of projecting this data. Something that it is very, very important is what Luke calls the Coordinate Reference System, the CRS. No, it is a formal representation of a location. He says that Geoda incorporates its own CRS. So the CRS for Geoda is what it is called the Proj 4 convention, which is compatible with the open source library upon which the projection functionality in Geoda is built. This is how Geoda tries to be open source. Everything is open. And well, the point is that, let's see, as Luke says, it is curious, but when you have a non-projected, let me show you, because it is very, very interesting how he explained that. But well, what it says more or less is that when, even if you think that you have a projected map, as it is my case here, so I could think that everything was correct. So sorry, I'm going to, as you remember, you can change the transparency of the map in order to look better to the point. So, or you can also here make the point radius bigger, so change the radius in order to have a better view of the cities. So they are apparently correctly depicted, but sometimes it is because you have this latitude and longitude degrees. So they are the latitude and longitude coordinates, and they are in decimal degrees, as it is said here. So so one of the main purposes or main issues here is to recognize whether spatial coordinates are projected. Typically, it is in units of feet, of meters, or unprojected when they are in decimal degrees. So it is curious because when I have the decimal degrees and I use Geoda, at least when I use Geoda to transform these x and y's into points, I'm going to build a map. The map will be apparently correct, but it is unprojected, you know, and this is an issue. So Geoda, in the last versions, so it was also very interesting for me because I didn't know that, but in the last versions, Geoda allows you to give a projection, which is very interesting. So I will put here, you know, like a spot, because uses this Proj for format. So here I am in the CRS item, okay? So, and down, well, look, so ask us to go to this web page, in which you will see it is a very useful resource, because this site as he says, contains literally hundreds of projections definitions. This is why it's so messy. These hundreds of projection definitions are, oh my God. And well, but you can find, this entry that is the one that corresponds to the latitude and longitude degrees. When you have the latitude and longitude degrees, so it is because you have a lack of projection. But the code is the EPSG code, and particularly 4326. So if you enter this code into the web page, it will lead you to this sheet. And if you want, the most important thing, if you don't want to go to the to the web page because it's going to be a mess, but the most important thing is that when you have these x and y's latitude and longitude coordinates, you can give by yourself the projection, which is fantastic. Let's go to the map in order to show what you can do. If you remember, well, I thought that it was great and I had a very good database, but if I try to add that, I can add a new layer. So the main layer is going to be the first that I've opened, but I can put new layers on this first one, and even Geoda allows you now to interact between layers. Well, perhaps I don't have time, to tell you everything about Geoda, because the last versions of Geoda are very complete, can do many things, even as if Geoda were a real GIS, which is not, at least for the moment. And well, if I try, to superpose these functional labor market areas that were had their own projection, I couldn't see them. So in fact, boom, it goes out. So it's very aggressive. Let's go again. So I don't know why. But perhaps if I try to put without the layer map, yes, it is quite unstable. So this is the issue. So it is free, but you have to pay for this freedom, at least for the moment, because sometimes it explodes. So I'm going to add now this, and what I could see is that well, these small points are the points of the cities, and the good map is here. So this is the map that was projected with this. It is a polygon map with the areas. So since they are areas, functional labor market areas, well, it is a map that has these areas that are not the regions. So Chile, like most of the countries, I think we have all these administrative units, but they're not 2, not 3 in Europe. But the thing is that these administrative regions, they are not exactly economically based ones. So if you want to have some kind of functional labor market areas or similar, they are not going to be of a lot of use, because these administrative regions, perhaps they are historical ones, and who knows why they were built. So in every country we have our own history with our regions, and well, but they are areas, so I can see the areas, but where are they? I thought that my map was correctly depicted, and it is not. This is the point. So what can I do? Well, Anselen recommends us to save another map, but with this copying, this sentence that we have here, in order to give the latitude and longitude coordinate map a projection, a corresponding projection. And in fact, this WGS 84, that is very common for many maps in the world. Of course, it is not the only one, since he here, for instance, talks about the UTM, which is quite common too. And for the United States, you have some others that the geographers usually employ. I can't remember the one, but it is like North American something. So, of course, hundreds of projections, as I said. So how to deal with it? So if I come here to File, Save As. Oh, sorry, what I'm going to do is to delete this one in order to avoid problems. I can remove. Remove is so I must put here and select remove. So I remove and come to, to the first map, the unprojected one. So what I must do is this map, the Chile map, store as, save as like a Chile map 2 or something similar. So I can call it Chile map 2. So is this the second map with the projections? And here in this CRS project for format, I must post this sentence. Oh, okay. Can you see? So if I do that, I'm giving this unprojected map a projection, particularly this widely common projection, this WGS84. And okay, save successfully. And if I delete everything and start again and say, well, please open the new one. Okay, again, the same thing. And open the cartoon. Again, it seems okay. And touching, open the FLMAs. And they are okay too. Right? So if you have the question of one of you at the beginning of the class, the latitude and longitude, it would be very okay, but please don't forget, if you want to compare with any other maps, to give a projection. So I recommend you to work always with projections, because if not, when you will be going to create your spatial weight matrix, I don't know if you remember, the other day, Geoda gave me an error message or a warning. Please pay attention, your database is not projected. So I'm not going to compute correctly distances. And for us, distances are very important, since, as you will know, because you have studied spatial econometrics, all of you, you know that we need a definition of neighborhood, and most of them are based on distances. So, well, I can change again the transparency in order, okay? So distances are very important. So perhaps, or not perhaps, for sure, I should recompute again the distance weight matrix. If you remember, yesterday we did that, and well, I have this weight metric already stored. So if you remember, let's see where, here, the inv, our inverse distance, or distancia inversa in Spanish. So this inverse distance weight matrix is the weight matrix that I computed, but perhaps it is not correctly computed. So I should overscript, you know, and now that I have the projections correctly suited, I should go to Tools again, Weights Manager, and compute this new spatial weight matrix. If it was correctly done, I just only had to load it. Load because it is already built. But since I suspect it is not correctly computed, I should recreate again. So I created, and oh, I had if you remember, in the other map, in the Chile without the 2, I added a poly ID, if you remember. So it is this ID variable that it is needed, you know, to identify with only one number the units, to avoid names, other kind of codes. But what happens here? Why it has disappeared? Maybe, well, I can add a new one and that's it. But perhaps I'm going to duplicate it because it is already there. Let's see if I add a new one. He says that I had an existing variable. Well, perhaps I can subscript. I don't know. No, it gives you an error. No, I cannot add a new one that it is. Well, you can change the name, or you can look at it. Oh, what is happening? Why this poly ID? Because maybe the format is not the correct format for an ID. Let's go to table and see what I say. In table, you have now a new menu. Well, it is new in the last versions of Geoda that allows you to change the properties of the variables, of the fields. And if I press here, I can see what I was suspecting, that it is a real number with even 6 possible decimal places. So it is not going to be recognized as a proper ID. So perhaps it is very easy to say, no, not a real, but an integer, please. And I forgot about the decimals, and that's it. So, well, I have changed. I recommend you to save what you are doing, because as you have seen, Yoda sometimes gets angry and puts you out. So please save everything and come here again. Well, let's go again and create and now the poly ID is highlighted here. Okay, well, better. I don't like duplicating fields, as you can see. Well, I can build a contiguity weight, a distance weight. If you remember, I went to the distance weight, and now instead of computing the Euclidean distance, since as you have seen, Chile is a very long country. It comes, well, not exactly from the equator to the South Pole, but more or less. So I recommend you, when you are dealing with continents, with very large countries like Chile, not like Spain, because it is not very large, but to deal with instead of Euclidean distance, but this is a straight line, come, for instance, to the arc distance. See, the arc distance are considering that the globe is spherical. So, and not in miles, but in kilometers. At least for me, I manage much better in kilometers than in miles. So what I see here is that the minimum distance band, what it represents is 193 are the kilometers, the minimum amount of kilometers. So as one city can have at least one neighbor. Well, sometimes when you have very isolated cities, it gives you very long or very wide radius. Maybe they are not, I don't know, they are not very suitable, or we should try with any other spatial weight matrices. Well, in this case, it is more or less 200 kilometers, which is not a lot, considering such a very large country. So 200 kilometers is no, even for Spain, you can consider as neighbors cities that are 200 kilometers far in a radius of this, on this radius. So, well, it is not that bad. I think that it is because these southern cities that are here in the south part of Chile, that they are farthest apart from the others. And well, now we also use the inverse distance. Why? Because 200 kilometers, in fact, are not too much, but they are an issue. So they are 200 kilometers. So we preferred to use the inverse distance as weights. So I'm not weighting the same a city that is exactly 200 kilometers from me than the one that is like 10 kilometers, like in a metropolitan area. That sometimes it happens. So this is why I use the inverse distance. So the ones that maybe are at 200 kilometers are more or less weighted like 0 or 0.000 and a 1, who knows where. where. And here, if I create it, I can overwrite the one that was created first. in order to avoid, to have a lot of issues in your hard disk and getting putting yourself into a trap that sometimes happens. You have so many things that you make mistakes because of that. So it is important to be clean, even like cookers. Cookers, when they are cooking, they must be clean at the kitchen. Well, here is more or less the same. So avoid duplications that are not necessary. And well, this is a piece of advice on my side. So it says that it is already exists, blah, 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 replace. And now I don't have a warning. Weights 5, blah, blah, created successfully. Success. So great, I'm happy. Okay. Well, Geoda gives you some main characteristics of your weights matrix. Like in R, if you have used or computed weight matrices in R, it is more or less similar. And you had this connectivity graph. If you remember, it was very, very thick. And it is because of this 200 kilometers radius. But as I said, all these connections do not value the same, do not give the or have the same value for all the cities. It is a very messy part because I am in the center of Chile with the metropolitan area. If I go to the northern part of the country, things are not so thick because cities are more isolated, one from another. Okay, and so I'm happy now because I have this correctly done spatial weight matrix. Of course, I can compute some others, even change the bandwidth, or even giving a power 2, as it is normal in the gravity models. As you know, for spatial econometrics analysis, in fact, it is good that you try with different spatial weight matrices in order, to see if your outcomes, if your results are robust. So if they are robust, using different kind of neighborhood definitions, you can be more or less confident of your results. Because as you can see, it is quite a bit arbitrary. So the election of the spatial weights matrix is quite arbitrary. So perhaps you are not considering the best definition. This is why it is interesting that you can contrast your results. And of course, if you opt for a contiguity weight, some of you perhaps are wondering, oh, but I cannot apply the queen contiguity. Well, perhaps for the labor market areas, but not for the green dots that are the main issue here. So I'm taking into account these green dots. And so how computing the queen contiguity? Well, maybe you are you know about that. What it does, what the Geoda does is automatically, so it doesn't show you, but what it does is creating artificial regions, considering that the green dot is the geometrical center, like if you were building isodistance areas with the Thyssen polygons or the Delaunay polygons. Well, they are the same concept. So, for instance, I can do that. And what Geoda does is build, without showing you these areas and compute the this sharing a common border issue, because the root contiguity or the queen contiguity suppose that regions are, like a checkerboard squares. So, but I have no the squares here because they were built previously without showing you. If you want to build these squares by yourself previously, you can do that. Excuse me. I'm going to hidden. Oh, where is it? You must look for this small square here. Perhaps if I eliminate the FLMAs, remove, well, doesn't matter because I have this base map here, so I cannot lose more or less the reference, the spatial reference for the cities. And I could build these polygons by yourself. For instance, if you want to determine or to compute trade areas, for a very simple cases. As you know, you need gravitational models like the Rayleigh model, the Huff model in marketing. But if you are, for instance, considering not cities that can have a different size or a different mass, and you should consider not only distance but mass, like in the gravity, the Newton's gravity model. But suppose that the mass is more or less the same, so only distance will be determined, important or significant. And in which cases these points could be more or less of the same size, not in the case of cities, of course, but in the case of the supermarkets of hypermarkets. If they were hypermarkets, you could build only with the Thyssen polygons an approximation to the trade areas. Because if you suppose that the surface is going to be more or less the same for each of them, as I said, only distances are going to determine the trade areas. Well, it's a very simple way to do that, but I recommend to my students in geomarketing to do that just to have a first idea. Of course, it is not very correct, and you should use some other algorithms, even estimation methods, etc. Well, let's go. The Thyssen polygons should be here. Okay, so in options you have many functions. Sometimes they are repeated from other menus, but this one, the Thyssen polygons, are only here in the options menu. You can display, and you even can save them as a different map. So it would be the map for the Thyssen polygons or for the trade areas, as you wish. As you are going to see, you have the ocean included in the trade areas because it is very simple, you know. But they are like trade areas, okay, more or less, because you need the Argentinian dots just to see if this dot will have this area in Argentina. But if you avoid these issues, it could be, as I said, an approximation. And this figure could be a map. Could be a map if you, let's go, for instance, if you approximate, like here in Santiago, it is quite interesting. Suppose that they are supermarkets, so you will have something like trade areas. See, perhaps not in the coast, of course, but okay, if I want to store, if I would like to, because it is not necessary for what we are doing now, but if you would like to keep these trade areas or quasi trade areas map, you can do that in here in Save As, okay, and you can give with this projection again. Oh, sorry, excuse me. I don't know if I'm sure if I'm doing correctly. Perhaps Thyssen polygons. You have your own menu to do that, because if not, so in Save As, it will be going to save only the green dots. So if you want to save the Thyssen polygons, you should use this specific menu. Also, you have the projection, the same one, and you should give this map a different name. Okay, I'm not going to do that, just to show. And this is what Geoda does internally without showing you. When you ask it to compute the contiguity spatial weight matrix. So of course the dots have not common borders, but if you define the trade area, you can suppose that this city shares a common border with this one, and this is the common border. So it's a way of having the regions without having them initially. And this is what Geoda does. And you can compute this kind of weights matrix. You should create it. And even you can compute the order of contiguity and so on and so forth. And let's go. We could create it if you wish. Well, it is going to save the spatial weight matrices with the same name of the map. So I don't recommend that. So I prefer you to give like the inv or whatever other name. So in this case, since it is the first W matrix, for me it is the first because it is the contiguity, at least the first thing being, applied in spatial econometrics issues. So I can save it like the first contiguity matrix. Well, here perhaps you are wondering why selecting the queen, not the rook. In these cases, when you have irregular cells, well, it is more or less the same. So it is very, very difficult that one, perhaps you can find that one region only shares with another a vertex, but normally it is not the case. And sometimes you have a little tiny part of a segment, and it is going to be like the queen contiguity. So the rook exclude the vertices as a neighborhood criteria, but as I said, when you have irregular polygons, more or less everything, the queen contiguity and the rook contiguity are going to be the same matrix. So just in case, I select the queen. Why? Because I work with socioeconomic phenomena. What happens in socioeconomic phenomena? That neighborhood depends on transportation, on vehicles, on roads, and it is not an issue if two provinces or two regions are sharing only one axis, because if through this axis goes a road, or a railroad, so this is why I prefer, but it is only a recommendation, because this is not a theoretical issue, okay? A different issue if you are working with agricultural topics or some other kind, or in ocean or with the ocean. For instance, I see that the biologists that are working in the oceans, they use these squares that they are like a checkerboard that are depicted from a satellite. And in these cases, maybe it is not the same if you share a border or a segment than if you only share an axis. Of course, yes. So I'm talking about most of socioeconomic analysis in which sharing a vertex could be more or less the same as sharing a common border. In fact, in Spain, that we have lots of mountains, sometimes there are provinces that share, a border, but it is as if we don't have the border, because you have a big mountain there, very complicated to jump and go to the other province. Of course, we have roads, but sometimes this border is worse than a vertex with another. I'm referring to, if you know Spain, Madrid with Avila. So if you want to go from Madrid to Avila, you have the mountains. You have, of course, roads, and you can go, but much complicated. That if you want to go to Madrid, from Madrid to Cuenca, that you only share almost a vertex. It's not exactly a vertex, but almost a vertex. Much easier, of course, much easier. So this is why, since I have this experience, I recommend computing queen contiguity. Okay, well, but this is not, of course, something necessary. And it was completed. It was done. Okay. I can now analyze these two ones. So the weights matrix, in this case, the histogram, it is the classical histogram that says that the number of this part of the histogram that goes from 5 to 6. So it is, let's see, it is, no, 4 to 5? Oh, 4 to 5 and 5 and 6. Okay. In this case, it is closing 5 and opening 6. So it means having 5 neighbors. So having 5 neighbors, like having 4 and 6, are the common, this is what predominates when I build these Thyssen polygons here for the Chilean system, urban system, and this is what predominates, having 4, 5, 6. If you try with any other countries, any other systems, even with very disaggregated sub-areas like census tracts, you will be surprised, because this number of neighbors, like 4, 5, 6, as much 7, they are the ones that predominate almost everywhere. Okay, So, and now if I try with the connectivity graph, well, I see that it is more sparse. Okay, more sparse and perhaps more realistic. Well, I don't know, because remember that the one that we built previously, I was applying inverse distance. So yes, it was 200 kilometers, very thick connection graph, but not all the distances weights the same, of course. And the connectivity map will give you the neighbors that share this common border, particular border that was built with the well, it could be interesting if you know the cities. These ones are going to be considered, and you can, for instance, make a decision. Well, I rely on that or not. I don't rely because this one in the north is very, very, very far, and I have the mountains or whatever other reasons. Okay, but well, it is interesting that you know these menus, but I think that the most interesting thing, okay, if I would like to join to this new map, so this new map, I can see the table, so the variables that are there. And if you see, I don't have variables. So I need the population, I need the log of population. If you remember, I computed all them in Excel. I could do that here, but in Geoda, it's going to be larger to compute by hand. There is not a, it is better if you want to use Geoda, not R or whatever other software. It is better if you compute everything in Excel, remove the formula, and put on a map. You can do that, but if you remember, I had the database stored here in population. So in population, I had this database, and what I did was removing from the first one that was stored in XLSX. This one, I removed the formula. So these are the logarithms, the LP, the logarithm of the population. P is only population of the cities. And even I had also computed the relative log of population, because this relative log of population is the variable that will be used, for instance, for the kernels and some other analysis, the Markov chains, because they are quite interesting, because I'm centering all the distributions on one. Because if not, even with the logs, they are going to have different different average and in different median values. This would be interesting for one analysis, but not for another analysis. For instance, the Markov chains, you could see the Markov chain for different periods of time, even if the averages are different for the different variables, but because they were relative to the mean value of the country. So in these new variables, this MLP, the mean value is going to be 1 for 1930, 1940, so on and so forth. Okay, this is why, well, I had all these variables computed, but they are out from my map. So how can Geoda add this data to my table? I can do this quite quickly. It is good to do that. In table, I have the option to merge. As I said, I need a common field. So a field that is a character, and well, I recommend you that though it is a character or a string, it could be numeric in order to avoid problems with names or even letters. But if you prefer, you could also use these letters. But I prefer to use field 1. I'm more confident of that. So first, I am in Chile map 2. Okay, so I need to call the other field, the other file. So where is the file, and which is the format? So the format is an Excel file, and it should be in the same directory. And yes, it is, but it is here. So population XLS. If I open, I can merge using this common field 1, that it should be here. And if not, I must add it, and I recommend you to manipulate the non-map database. So when you build a map, like a Chile map 2, you shouldn't manipulate it outside. Well, it is not easy in Excel because it is a DBF map. So the DBF is the format for the table. But sometimes I have something that is a trick. So I keep a very old Excel, a very old Excel software, very, very old. But with this old Excel software, I can manage with the DBFs. But please, if you want to do that with a map, you must take into account, you should know, that you cannot change the rows order. So the rows must be in this order, because if you change it, you are going to make a lot of mistakes with the representation, because you haven't changed the shape file and the SHX file of the map. You are only changing outside Geoda the rows with software like the old Excel that allows you to store the DBF, because the DBF can be opened with the modern Excels, but you cannot store it. Okay, so be careful when you have a map. Don't change the rows order with an external software. If you want to do that, do it, but inside Geoda, GIS, or whichever other GIS you are using, because they are going to do it properly, taking into account all the files of the map. So here, what I'm going to do is, well, if I press this button, what it is going to do is including all the values. Maybe it is better because, well, I have some that I don't want, but they are only 3. And I can exclude them with this sign. And how now what I'm going to do is including the population series, the log of populations, and this relative log of populations. I'm going to consider the same field. As I said, if you don't have this common field, it's not going to be possible, or if you want to use the names, it could be a mess. So I recommend you to have this field, and I'm going to merge, and well, okay, merge. Oh, success. Okay. So what is happening? That the Chile map 2 now has the new variables. Well, perhaps I should change the formats or leave them. I don't mind if leaving them. Why? Because well, the population is not an integer, so it is. Sorry, it's not a real characters, real number. So I should perhaps change it into integer. But if I don't need to do that, I can keep the value as it is. And now, yes, of course, it is important in this case for the logs and for the ML, etc. So what happens if I want now to compute these interesting charts and even the Lisa maps that some of you were asking me, if I want to do that with Geoda? I must first say Geoda that this map or this table, well, the map, the whole map, is not, or it is not going to be only a cross-section map, as it's normal. So it is a cross-section. If you see, what I have is the list of the cities, the main cities in Chile, that are 184, but I don't have a pool, I don't have a panel. Perhaps you say yes, you have, because you have here the population in 1930, 94. Yes, but Yoda do not know. It could be a population in 1930 or percentage of unemployment rate or whatever other variable. So you must say, as in any other software, that it is a panel. Okay, even if you work in Stata, you must say so. And in I think all the packages. And now the way to do that is here. You see this clock of time, or even in this menu of time, you have the time player and the time editor. Well, first, the time editor. This is what we need, the time editor. If I use the time editor, well, Geoda is asking me for the variables, the name of the variables, and the moment of time. So if I select the complete set for population, just for population, and I say include, look, a new group variable is created. So it is going to create a panel. It is like a superposed table or a new table that Jude is going to create without distorting the map. So the map is going to be the map. I'm not going to repeat 8 times each of the cities, but the table will have a configuration of a panel. And here it is better if I substitute the time 0 by 1930 or the time 1 by 1940. It is better for the computations. 1952, 1960, 1970. If you have many time periods, it's going to be a little bit boring because there's not an automatic way of doing that. 1992 and 2002. Well, Anselm for the moment thinks that when you have this spatiotemporal analysis, it's not like most of the spatiotemporal analysis for which the time series are very long and only 4 units for spatial units. No, like 4 countries and time series of 50 months or whatever. No. Here our scope is spatiotemporal, but what predominates is the spatial thing or the spatial dimension. So in this case, I have 181 spatial units, or the cities, and only 8 time periods. Okay, and well, if I select everything here, I will compute or I create this new grouped variable. Of course, I could change the name, and it was here P, but it could have been some others. The good news is that the time periods still remain there. So it is very easy now, to select all the time series. Now you can call it like LPOP or whatever. So LP, it is not that bad. Okay, the suggestion. And now for the relative log population, and again the suffix. Okay, now I could, if I wanted to, it is not necessary, okay? I can start working with this time editor. I can close and start working with it. For instance, start working. I want to build the box plots. If I say, please build the box plots to P starting, it doesn't mean that it is going to represent only the 1930. It's a way of saying starting in 1930. And I say, okay, this is what I have. Nothing, because the population. So the difference between the population of Santiago and the rest of the country cities is huge. So perhaps it is better to select not the population field, but the log of population. This is the box plots that you could see in the slides. Okay, you can see the more easily if you have a convergence, divergence, this value of the median value. If you remember, these lines, like orange lines, are the median. These green ones, are the mean values, and you have the outliers here. If you remember, during the first years, I could find some outliers, even 3. Well, this one is very close to the hinge, but from 1970 to now, to the present time, the only city that really has such a big dimension or size is Santiago, is the capital. And the other ones, we had this kind of convergence towards, a point towards the average, but the average is over the median. Okay. So I could compute this box plot automatically, which is very easy. But what I was saying is that if I come again to this menu, the time player and the time editor, if I need to have the panel in the form of a pool variable, like this one that was the initial. If you remember, this initial panel that sometimes you find in this way, but some others you don't find the data in this way. You find the data directly with in rows your regions, and in columns you have the years. What about if you would need the pool? I can build it directly, and even the weight matrix as a block weight matrix, considering the different periods of time. Let me show you here, safe space time. I could give CRS if I need it, but no, I'm going to ask it to store like or a CSV or like a DBF. If I select a DBF or an open document, well, the name is untitled, but I could call it panel. If I call it panel, what I'm going to do is storing the pooled dataset. So the other configuration, the second configuration in the form of a pool dataset. And if you have a spatial weight matrices, the spatial weight matrices or the spatial weight matrix that is active. I don't know the one that is active. We could check first. Well, the active one is the one that you have it the first place or selected. So I have selected this queen contiguity. If I want to select the inverse distance one, because it was the one with which we were working in our paper, so I prefer to select it and see what happens. Even I don't know if it is going to to store the two ones or only the selected one. And well, let's go again and select this DBF or open document spreadsheet or whatever format you prefer, and I'm going to call it pan and save. Okay. Oh, why? Column index. Oh, maybe it's a problem. It's a problem with, oh, what a pity. Let's see. If, oh, as you see, I have here what only the first years, because the other ones are behind. I don't know if it is because the poly IDs. I have two fields that are named with the same word. No, I don't know. Oh, what a pity. What a pity. I would have liked to show you. Oh, well, maybe, no. It hasn't created the panel one. Oh, what a pity. Oh, why? Oh, whoa. Oh, well, maybe you should rearrange everything, but I don't want to do that. Or I can do that, but very, very quickly. Oh my, what a pity. I would have liked to show you. How can I show you? Perhaps the best thing is ungroup the variables. 52, 60, 70, 80, oh. Well, I don't know. Perhaps if I try with comma separated, I think it's going to be the same. Save. Yeah. No. Okay. Oh my God. Something happened and no good. I didn't store. Oh my God. I didn't store the map. Oh, I must do the same issue again. Well, let's see. I have this bit, the poly ID, metropolitan region. I think that everything is correct. merge. Well, I will do it very quickly. Sorry. Excel. It was in population. Open with the field 1 and the field 1. Include everything. Exclude, exclude, exclude. And I think that they should be merged. Success. Okay, and maybe it's because I have blanks somewhere. No, I cannot find them. I'm going to store this database just in case. So Chile map 2, again, the menu. Let's see. So the population. Well, I will do that only with the population, or the log of population, not the mean of the relative. 1930, 1940, 1952, 1960, 1970, 1982, 1992, 2002. So if I press everybody, put them, and do the same with the logs, because the logs are important because of these scale issues. And well, let's see if I can now. Save space-time, table weights, like a DBF again. I choose the DBF because it is quite simple. Panel and save. Yes, replace. Okay. Oh, success. Okay, good. If I but now I I had not the. So if you enter again, you must upload or load the weights matrices. So no weights matrices, so I couldn't create. So let's go only for the inverse distance. Yeah. I must be patient. So if you don't want to have these issues, you can create a geoda project as if in any other GIS. So if you, I will do that afterwards. Now I can save them again, but not only the database, but the spatial weight matrix. So panel, save, replace. Okay. Success. Okay, so if I come here and look for the panel database, what I see is it is a DBF, as you can see. I can open with an Excel. In my case, I have configured it to open it easily with Excel, though I cannot edit with this new Excel. And you will see that you have this pooled data set. It is a pool data set in such a way that so the first rows corresponds to the year 1930, and in the same order of the table of the map. So you don't have the names for the cities in Chile, but you know that this is the order in the map. So, well, it is okay. Because this ID, STID, as you see, STID comes from 1 to the last. So it is not an ID for the regions. It's an ID for the complete panel, from 1 to 1472. Okay? The complete panel. And this time dummy, well, it's a dummy for to identify the time series. So I have this 1930 first with ones. If I adjust here in view, like let's see here in view or in data. I cannot find it. Or no, immobilized. Okay, I can fix the first row in the two first columns. And what I see is that I have the population ordered, as I said, by regions in the same order like in the map. And when I go to 1940, I will have the ones in 1940 and so on and so forth. But the most important thing, perhaps, is not this pooled data set, which is also important, of course. But for me, it's very, very interesting to have, in the same way, stored here in examine well, not only the Excel archive but all the files of the archives. And what I have here is let's go for the panel. The panel, okay, GWT. As you know, the GWT is the classical file for the weights files when they have been computed using distances. So if I open this file, well, this is the typical sparse weight matrix. The sparse weight matrix, what it says is that for observation 1, you have repeated as many times as cities that are neighbors to it in a 180 something radius, point radius. And this is the weight. It is not being at a distance that at any other. So the weight will be higher for cities that are closer, as it is logical, because it is the inverse distance. So if I ask for the limited division and I ask it to, to divide the columns using the spaces, and I finalize, I could use again the pivot table in order to show you that this is a block matrix. So it is a matrix, a weight matrix, but made at blocks. So I can change because it is easier. Oh, sorry, I again have problems with my laptop. I don't know why. The other day was the same. Oh, well, row, column. Well, I'm going to put that because I'm going to represent in rows and columns, and these are going to be the weights. I will eliminate this one. So I can build, well, again, perhaps, I don't know if it is necessary, but I can build the pivot table. In insert, I can come here, a pivot table, or dynamic table, and organize as I have done. So in rows, the first column, in columns, the second, and in the cells, well, averages or sums, it doesn't matter here because they are not going to be repeated. So rows, oh, no. Weights are going to be, oh, this is not correct. Oh my, weights here and rows, let's rows here, okay. Oh my. Okay, that's it. Well, I have lots of decimals, but well, I can rearrange the decimals and perhaps fit only one or two, just to have a better view of the complete matrix. As you can see, for the columns enumeration, we have lots of columns because it is a very big matrix. Well, the cell format, let's give like 2 decimals. Oh, sorry for my laptop, doesn't go very quick. So it's because maybe I could fix the columns and have a better view. If I close this menu for the pivot table, I could see. See, no, doesn't want to close. Perhaps I can select just the, since it goes too slow. This is why I didn't want to do that. As you see, we had weights in the first part of the matrix, and I will have weights in the last part of the matrix. Oh my. I don't know. Oh. What a bit. Yeah, here it is. No, it was 1,400, if I remember. What? You see the numbers here? It is because the blocks. So these are the weights that they should be the same weights, of course, but you could change them. These are the weights corresponding to the last period, to the year 2000. So if I only copy, avoid the totals, and open a new sheet, oh. But I wanted you to see, oh, it is going to take a lot of time. Poof. Oh my God. Okay. Yes. So. Oh, no, something weird has happened. I prefer this. I'm going to put the zoom at a very low value. Here, the zoom in Excel. You see these very small numbers? What I want to show you is how the blocks have been organized. Oh. Here is the second block corresponding to the second year. If you come down, you will find the third block corresponding to the third period of time, and so on and so forth. This is what I wanted you to see. Okay? I will store it just in case I need it for something. Oh, archive is store as, so save as data for classes, and well, it's like a weight matrix. The imp stack or pool. And instead of storing it as text, I should store it as Excel in order not to lose the information. Okay. So now, if I want to do something, well, it is the same as with the box plot. But for instance, if I want to represent this mean, these mean values per period for the whole cross section, I can do that. No, this is not. This is the spatial correlation. Now here, it's very similar. So I can prepare the averages chart, and the averages chart is like a difference in difference analysis that allows you to see if you could have some kind of regimes. The limitation with this analysis, with this chart, is that it only allows you to select one part of one regime versus another one. So only two regimes. So the selected versus the unselected. You can select on a map, as we did yesterday, or doing that in an automatic way. Here in table is like selection tool, a new selection. The selection variable could be the metropolitan region. So I will put the ones in one part and in another, just to select only the ones, okay? Because it is from one number to another. If I put here from 0 to 1, I select the whole country. This is what I did the other day. So I select all in range, and I can try here in the map to see if I have selected correctly the metropolitan region cities, and they are. And what I have done is analyzing the selected versus the unselected for the ID variable. So I don't want to make the selection for the ID, but for the log of population, in order to avoid the this scale difference in scale with Santiago. So in logs, wow, this is this chart that we could find in the slides. On the slides you could see this difference. So Santiago at first, the metropolitan cities. Well, Santiago has been always a big city, but not the other ones. And the degree of of agglomeration was very low, and the rest of the metropolitan cities grew a lot to catch up the biggest ones in the country. And even now, in the last years, they together some more population than the cities in the rest of the country. This is what I'm saying. And if I want to test if these differences are or not statistically significant, I can do that with this p-value. This p-value for the f. Well, the f is a kind of show test, but it corresponds to the t-test. This 0.089 is the p-value for the t-test if I run a diff and in-diff test. In this bottom, I have the diff in diff, and this is the probability or the p-value, so the 0.08871 for space. Well, space is a variable, as you could see, that has a value of 1 for the metropolitan cities and 0 for the rest. Okay, and this is what we have done for one of the time periods, for 1930. But what happens if I analyze these differences for 1940? The p-value is even lower, so they are more significant. And diff in diff will give me the same result. But for the moment, being in these metropolitan regions means having a lower average in population. This is what this negative sign means. I cannot go in depth to the difference in difference model, but this is what it means. So it's a very simple one. And if I go, for instance, to 2002, again, the p-value is quite significant. So what I can see here is that there is an inflection, an important change in the evolution of the metropolitan region cities with the rest of the country. And at least I should recognize, or I should consider two regimes in this country, because I have a different evolution, different kind of, structure maybe, and in many senses, not only from an economic point of view or a demographic one. And in fact, if I analyze differences at the beginning and in the end, they seem quite different, quite significantly different. Okay, this is what this analysis makes. But it is not completely, definitely. Why? Because I don't know if in the northern area or in the southern area I'm going to find similarity, or if they are not similar. I could, of course, do the same with the northern cities compared to the southern ones and using this chart. But perhaps it should be also interesting to compute here in space, I have the possibility of computing the univariate local Moran size, particularly the Moran's map, to look for this kind of high, low, high-low and low-high significant points in the quadrants, if you remain the quadrants for the Moran's scatter plot. And if I do that for the log of population, in this time, because I could change another period of time, and for this weight matrix, because I could use some other if I would have, because I didn't load the contiguity matrix. This is why it is not here. I should have loaded previously to being able to look it here. So I say, okay, a cluster map, and I can see the cluster map, this cluster map I showed you in on the slides, and you see that there are some big cities here, some others here, but maybe in this part, in this middle southern part of the country, I have a concentration of big cities, maybe along the main road that goes from up to down, that is, you know, connecting, even it connects Peru. It is a main road, a main connecting road among countries. And perhaps, well, I'm not completely sure. And these dots, well, they are low-high because they are low population but surrounded by high population cities. So it is interesting, okay? Because I think that it is the Pan American road. I don't remember, but well, so perhaps these subspaces are not so uniform as to consider as a whole, and different, completely different from these others. But if I analyze the evolution, because this is the main way to do that, I can use the time player. The time player can be static. If I press here at this bottom, I can go from the map, but for 1940. The main interesting thing of this map is that these dots, the ones that are different from the gray ones, are statistically significant because we have previously applied a permutation approach. Well, you must, of course, make a revision to the, I cannot explain now the Moran-Psi computation, but this is the main interesting issue with respect with the scatter plot. And, well, I can go from the past to the present, and in, you know, 1970, when Pinochet rise to power, we had this situation. So we started having different hotspots. So having important differences among cities in certain areas of the countries, so a polarization. And I go to a diffuminating pattern of these differences, so to a convergence, okay? Because I am diffuminating this, so cities are growing, and in 1982, almost convergence. But what happens during the 80s? In the 90s still, but in 2002 is again new, you know, hotspots of high values or low values arises in the country. So we go to a convergence trend, as we could see, but convergence trend got slower for these cities. And well, this is an interesting conclusion, and even it's a way to see that the evolution in the northern cities, it is not exactly the same as in the southern one. So perhaps this is why we went in depth into the differences also in terms of historical terms of these cities, and decided to split and recognize 3 areas in Chile in terms of spatial systems. Okay, I can press from the old time, you know, the older period, and I can press this button. And this button is a time player, but it will go automatically changing without pressing anything at speed. The speed can be slower or faster. I can make it faster and go beep, 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 beep very quickly. Well, this is something interesting that you can see now in many software visualizers. Okay, it could be interesting if you have many years and you can see with like COVID. This is the spatiotemporal diffusion of a phenomenon. So here it's not so stunning, like looking at the COVID rates in some areas. But for this kind of phenomena, this time player can be really, as I said, stunning, very, very interesting. And just to finish, just telling something. First, some of you asked me to explain better what I mean by what I meant last day by speed of convergence. So I have here, oh no, this is the recent ones. I have uploaded, well, it was a second version, now it is a third version for the slides. And why? Because I've introduced some issues that you asked me to introduce or to explain better. One of these issues was the one related to the convergence speed. So the convergence speed depends on the beta value, and the beta value, the slope b, or the beta hat value, estimated beta, in absolute terms, the higher it is the beta, the faster will be the speed. This is why in this first part of the Chilean cities evolution, we had faster speed, because in absolute terms, it is like 4.2% of speed, and this one, it is 3.1. Well, it is not exactly, because the speed must be computed applying this formula, but I could know, just looking at the beta, the estimated beta, in which period convergence speed is lower or slower or faster. If I want to know the exact percent, I should compute this lambda value. Other issue that you asked me to do, well, explaining better the Lisa map, I think that I have tried to do that with Geoda. And another topic, some of you asked me to explain better the kernel functions. Well, you can find, this description, I took them from eViews. I use eViews, so in eViews and many other software, you can find the good explanations. Well, this one I liked very much, so I put almost like it is in eViews, in the eViews manual. And well, it explains to you what a kernel density graph is. So I think that you should know, but perhaps not. So you can make a revision. So this is the definition that Julie Legalo introduced in her paper in 2004. So the continuous equivalent of a histogram. So I depicted here the histogram. So the histogram, you have here like 182 bins for the histogram, or intervals, and it has been interpreted like the black line is the one that is corresponding to 1930, and this is the 1930 variable, the m, because it is the average population in logs. So it is an approximation of this making a continuous chart. Of course, if I represent the histogram, I cannot see the same view as if I approximate this histogram with the kernel. And the kernel must be approximated using a smoothing line. And this line, this smooth line, is estimated using, a kernel density function that is defined as you can see here. You have some parameters that are going to change. So K is a kind of kernel weighting function. H is the bandwidth. Well, in N is the observation. So the observations, you all know the observations. The problem is how to compute the bandwidth of the kernels. So the kernels, there are many different ways of doing that. Normally, by default, the Epanechnikov function is the one that it is used. So in eViews, it is the one that is used. I think that it is the same in Geoda. We should check in Geoda. And Silverman proposes to use a database automatic bandwidth that is measured as you can see here. All these values are known. N is the size of the sample. S is the standard deviation of the variable of the distribution for 1 year, and the IQR is the interquartile range. So all these values are known. You could compute by hand the Silverman bandwidth, and using one of these kernel functions to have the kernel density function and to depict the continuous histogram. Okay, some others were doubting about how to interpret these three different regimes. So I tried, to extract them and to point out to different, the different evolution, how they should be considered, the northern and the southern, as different from the center. So the center is more or less like the distribution for the whole country. So I don't introduce the slide. Okay. What I want you to know, to do, for the next day, on Tuesday, is first answering. I don't know if I introduced in Moodle the feedback for session 4. Yes, it is here. So, well, I put in this chapter. No, it is not in this chapter. I will put this here. Feedback of session 0. Sorry. Okay. So please, the feedback for me is very important, because it's a way you have to tell me if you have understood properly everything or not. So please, this feedback, well, I think it is, I don't know, it is already open for you. I'm going to give you more time to do that until 3 p.m. Let's see, 3 p.m. Yeah, because the time is 3 p.m. So you have more time. Please answer. Don't forget, because as you are seeing, I give it a lot of importance. And this assignment 3, I will upload like this assignment function in Geoda. I will create a new one. I will send you an email when it is ready, because you must upload a first exploratory analysis with your database. So with the exception of the kernels, that I will introduce them in R the next day, for the whole, possibilities that I offer you, well, it's just only, it is not a lot, the box plots, and to comment about your box plots and the scatter plots, even if you think that you must split, because there could be a kind of structural change. And the Morantz scatter plots, well, the Morantz scatter plots in Geoda are here. More or less the same menu in space. The univariate Morantz gives you the Morantz scatter plot for each year. You can again play with it and see how the slope change. Okay, so please, it is important that you start with your database. You can put this data on a map. You can see the maps. You can compute the Morantz scatter plot, the normal scatter plots, to look at the convergence trends, the box plots, and the Lisa maps. That's it. Okay, for the next day. And sorry, because it is quite late, and I must. Oh, sorry.
Madam?
Yes, excuse me. I'm going to. I don't know how to stop it. Okay. Yes, sorry. Yes.
Madam, I would like to talk you about the internship.
Sorry?
About the internship next month.
Yes.
Yes, you have given me I show interest in internship with you. So you have proposed me some census. I am
Oh, yes,
Mark.
but
Yes, yes, I'm Mark. I wrote to you about the internship.
I didn't see it. I don't know why. I had lots of problems with my email. Please, if you don't mind, sorry, but resend me the email again because I couldn't see. I have many problems with our server at my university, and I lost many emails. The problem is that some of them I could see them, but some others I couldn't. So please resend me the email, and I could check and give you some flavor, okay, about what
Yes,
you want.
madam. I wanted to talk to you about that. If you can uh, give me something on environmental economics, I would like to work on that.
Uh, but yes, but you must look for the database.
Okay.
I'm not talking now about the internships because it is not the moment. So I
Okay.
prefer you to write an email, and
Okay.
perhaps
Okay.
we can meet some in another moment.
Okay. Okay.
But
Okay.
okay,
Yes, madam. Thank you.
the point is that you should look for a database.
Okay.
If you can, of course, that could be interesting for you, that
Okay.
allows you to make interesting analysis. If you can't, select whatever you find. Even if you go to the Geoda site, you can find some databases to
Okay.
play with them. But perhaps for you it is not the most interesting thing. But if you are desperate, you can use these databases. The point is that you should find the x and y's coordinates, or the map if you can. Okay.
Okay. Okay. Thank you, madam. I will write to you as soon as
If you
possible.
have any problem, please write me an email, and I
Okay.
will write you back. But sorry, because if I couldn't answer, it's because I lost. I had some problems. I think that the problems have been fitted, but I think
Okay.
only. Okay.
Okay. Thank you,
So,
madam.
uh, so that's it. It's quite late. Sorry, because it's 15 minutes late. Sorry.
Professor, sorry, very last question. So basically, we can select our own topics for thesis or internship.
But well, in the internship, well, I don't know exactly, because I must talk to Julie Legalo about your internships. The thing is that, as I said, if you want to work with a database for your internship, it would be great if you select this database in order to have a better knowledge of it. Unless this database you want to work with is not a panel. But if it is a panel, well, I mostly recommend you, unless you said, oh, I had lots of problems to geocode and blah, blah, blah. So please know, because you have only a very short time from now to Tuesday to prepare definitely your first assignment.
Okay,
So
thank you
you
very much.
must balance what it is better for you.
Yeah, sure. Thank you very much. See you. Bye-bye.
See you. I'm going to stop recording.